2009 Form B, question number 4. This is not a calculator question. It's a question involving polar curves or calculus of polar curves. And so we have this graph here. The polar curve r equals 1 minus 2 cosine theta, where theta goes from 0 to pi, is shown above. And S is the shaded region in the third quadrant, bounded by the curve and the x-axis. And the first thing we want to do is to write an integral expression for the area of S. Now it doesn't ask us to solve that, but just to write the integral expression for the area of S. You recall that the area under a polar curve is integral from alpha to beta 1/2 r squared d theta. So in this case our r is 1 minus 2 cosine theta. Our alpha, we need to find out what is the starting angle that begins to map out that particular area there. And so it would make sense to start at 0. When we plug in 0 into the function, we get 1 minus 2 times 1. So it's 1 minus 2, which is negative 1. Maybe it would help if we made a little map over there. And then second of all, so it's negative 1. When theta is equal to 0, we're going to reflect back through the y-axis, and we're going to end up at negative 1. Now, for the second one, it looks like it might be about pi over 4. Well, we want cosine theta to come out to be 1/2, so that would end up as being 0 there. So for cosine theta to be 1/2, we would use theta is equal to pi over 3. And that would give us 0. So basically, we're sweeping through the area from x equals negative 1 back around to 0. So that settles it, and I have written above there that our final area integral expression would be 1/2 integral 0 to pi over 3 of 1 minus 2 cosine theta quantity squared d theta. And so that's it for A. We want to write expressions for dx d theta and for dy d theta in terms of theta. Well, for our x's and y's, we have to remember that x is equal to r cosine theta and y is equal to r sine theta. So then dx d theta would be the derivative with respect to theta of 1 minus 2 cosine theta, which is our r, times cosine theta. And to evaluate that derivative, we could either use the product rule or we could multiply it out and then find the derivative. And so I'm going to multiply it out. And the derivative of cosine we know is negative sine theta. Then we're going to have a chain rule with cosine square theta. So I bring down the 2. Now I have negative 4. Leaving the inside alone would give me cosine theta times the derivative of cosine theta, which is now sine theta, or negative sine theta. So that's going to change the sign of from negative to positive in front of the 4 cosine theta sine theta. Alright, so that should do that. And if I wanted to simplify that, I do have the identity 2 cosine theta sine theta is equal to sine 2 theta. So I end up with negative sine theta plus 2 sine 2 theta. For dy d theta, I start out similarly with 1 minus 2 cosine theta times sine theta, distribute. And when I do, I get sine theta minus 2 sine theta cosine theta, and that is just sine of 2 theta. So I find its derivative. It's cosine theta plus or minus 2 cosine 2 theta. So for dx d theta, I have 2 negative sine theta plus 2 sine 2 theta. And for dy d theta, I have cosine theta minus 2 cosine 2 theta. And so that is parts A and B there. Now my answers may show up in a different form than the ones in the solution. I happen to think that the way we did this was a little bit more intuitive and straightforward without needing to know a whole bunch of formulas there. Alright, so we'll continue in the next video.